Yes, members, a good afternoon from this side. Hope you are doing good. This is Into Edwin, and I welcome you to our 30-second meetup, though it is the 50th meetup on Bevy. So today is our first meetup generally when we are using direct Bevy and the past we have been using Zoom. So today's session is advanced. It's all about advanced techniques in sheet metal. That is the art of precision bending or the art of bending. And it's going to be delivered by Mr. Deepak Gupta. He's from India. He's a SOLIDWORKS hero, he's a SOLIDWORKS expert, and at the same time he's a SOLIDWORKS champion for many years. I think Mr. Gupta, this is the fourth time when you are presenting to Uganda SWUG. The first times were in World Men's and drawing tours. So I think let's give in more 2 minutes and we can start off, Mr. Gupta.
Thank you, Edwin, for giving me this opportunity to share my knowledge of sheet metal with all of us. And hello, everyone. Uh, Good afternoon, good evening. Uh, I'm from India, and we have a good evening over here. And I would like to say thank you to everyone for being here. Today, I'm excited to talk to you about some of the advanced feature in solid sheet metal tool. We will be covering some key functionality today, which will help you to optimize your design flow and help you in understanding and getting a good grip on the sheet metal tools. Edwin, can you please make me a presenter and I can share my screen?
Okay, let me work on it.
Okay, thank you.
Yes, Mr. Gupta, I think I've given you
I have the controls now. Thank you very much.
welcome.
Just need to see. Oh, it's not letting me. Okay, let's start with this one. So I'll keep it up for a few minutes, and once we are ready, we can get started.
Yes, let's start in 1 minute. So as we wait for the 1 minute, I take this opportunity to welcome all members from different countries all over the world in different continents. You're welcome to Uganda SWUG, and let's keep in touch as we explore more in the design field. Yeah, because we just need persistence and consistency to perfect our best. And also, as the session will be ending, we have a quiz, and the winner will take home a 25 gift card, US dollars. So keep an eye. So just be mastering everything that Mr. Deepak is going to mention, and also feel free to ask any question. So, Mr. Gupta, the floor is yours. You can now take over.
Okay, thank you. Thank you, Edwin, again. Hello, everyone. Like I said, like we will be talking about some advanced feature in solid sheet metal still today, and I hope by the end of the session, you will not only feel confident in using the sheet metal tools, but you will also discover some new features or some new ways to optimize your design flow. And uh, we will be talking about some key functionality like sketch bends, jog bends, corners operations, using variety of examples along the way. And then, as Edwin said, we'll have a small quiz, which will be an online quiz which anyone can participate. So let's get started. So we already discussed the agenda. We'll be talking about some advanced feature. So before we jump on to the actual presentation, let me give a brief intro about me. So I graduated from a technical college in year 2000, and that was the year when I got introduced to SolidWorks. I have been using SolidWorks since 99. Actually, 1999 was my first year when the SolidWorks was introduced to me by a friend. But the actual or the heavy usage I started in 2005. And I believe I'm still a learner, and I keep on discovering new things and still learning a lot of things every day. I'm a certified expert and a champion. I'm one of the Michelle Swagan Community Award winner. I was recognized as one of the SolidWorks superhero and mentor. And finally, I work as SolidWorks design consultant with Vishnu Design Services. It's an engineering servicing providing company. And what we do over here, we do modeling drawings, and we also do automations here using SolidWorks API. So before we jump into the presentation, anybody wants to guess what this could be, what this image might be telling you, like what thoughts comes to your mind? Anybody wants to do a guess what it could be? Uh, Closed, yeah, yeah. Okay, underground cables. We are somewhere near to it. Okay, let me disclose the answer for you. So on left side we have the spider web, and on the right side we have some site which is under construction. Could be a farm site, could be a construction site. So it's website. So before we understand the different features of the sheet metal tools, let us first understand what exactly the sheet metal tool is. So sheet metal parts are basically a thin wall component where the thickness range from 0.5 millimeter to 6 millimeter. So that's a very basic range. But we do also get thicker sheet metal parts, or we also get like thicker plates, which we do not nominate as sheet metal. We generally call them as a plate. So anything above 6 millimeter, we call them as plates. Sheet metal materials, they come in like different materials. Like you can find them in aluminum, you can find them in steel, you can find them in stainless steel, even some are in copper. So the material is chosen being based on the specific need of the application, and what kind of operations we are going to do on that sheet metal part. So uh, there are two ways in general how sheet metal parts are made. So one common method is by bending using press brakes. Back in the days, or even I have seen like till today, some of the sheet metal parts are being made by hand, simply by uh, hammering and doing some other operations. Sheet metal parts are also made by forming like our trays or our sinks, kitchen sinks, or even some other parts, automobile parts, they are made by forming, which are special tools. Now, when we talk of SolidWorks, so SolidWorks give us basically two different ways to do sheet metal modeling. The first method is like we start using the sheet metal features right from the first sketch, sorry, first feature, and then we build up as per the part requirement or the part geometry. And the second option is we make a part which is complex in shape. So instead, and might be difficult to get started directly with the sheet metal part feature. So what we do is we create a solid or surface model of it, and then we use uh, convert entity or convert to sheet metal features to convert that complex part or even some imported body part or imported geometry part to sheet metal. So we'll be looking at some of the features as we go along, as we go along with the presentation. So continue on to the sheet metal overview. So when we create a sheet metal part, we get different features in the design tree, using which we can tell, okay, if this is a sheet metal part or if this is not a sheet metal part. So if you make a sheet metal part, either using the direct sheet metal features or by using the convert to sheet metal feature, you will always see a cut list feature in the tree. Then the next will be the sheet metal feature. And then finally, you will see a flat pattern feature in the feature tree. So in the cut list, basically it has the different properties related to the sheet metal in under cut list. Like we have the blank size is available directly into the cut list, the thickness is available into the cut list, and few more properties are also available. The blank area is also available, the length, width, and few more properties are available in the cut list feature. Using the sheet metal feature, we can control the bend radius, the thickness, the K factor, and few more features of the sheet metal parts. And if we have more than one body in the same part, we can have different thicknesses controlled by the sheet metal feature. And finally, the flat pattern feature. So it lists out different flat patterns which are there into the part, and we can by functionality we can have only one flattened state available at one single time. So if say we have like five different bodies into the part, and if we want to see the flat pattern of all of them in one go, it is not possible with SolidWorks. We can look at the flat pattern, flattened state of one single body at a given time. So let's look at the first feature, which is a swept flange feature, and I believe it was introduced in uh, 2012. And this feature is very helpful. We can use this feature for creating compound or complex bend. By compound, I meant to say like where you have more than one bend, and complex where you have complex geometries, and it may not be feasible to use standard SolidWorks sheet metal feature to create those bends. Like we have a tray. So if you want to create this rounded tray, you cannot use the standard sheet metal features to create this tray. You will have to use the swept flange feature. And if we talk of manufacturing, we would either need some special tools, or we will need some forming tools to create the actual physical parts, which was made by swept flange. Similar to swept flange, we have a miter flange that works almost the same way, and it can be also used for compound and complex bend. The only difference is that we do not get smooth rounded corners like we get for the swept flange. So let's look at one of the example. Uh, are you able to see my SolidWorks screen? Because I'm not sure, like, it's not letting me show you. Wait, let me just share it again. It's not letting. Okay, I'll share the complete screen and then we can go. I hope you can see my SolidWorks screen now.
Yes, the screen is visible.
Is it pixelated or is it like? Let me try to share it again. Actually, it's not letting me select more than one. Oh boy. Okay, let's try it again. So, are you able to see the screen without any pixelation? Or
Oh, yes, the screen is now visible on the screen.
okay. So here we have one sheet metal part which was created using the base flange. So we have a base, and then I have created a sketch. Let me just edit the sketch. So this is the sketch geometry, and this is a compound or a complex bend, because we have one bend over here which is for 120 degree, and then we have another bend over here with a radius on the top. And what we want to do is we want to use the sketch as the profile, and think of the swept flange uh, is similar to the sweep uh, tool we or sweep feature we have under the solid bodies feature. So it works the same way. You need a profile, and then you need a path. So I select the sketch 2 as my profile, and I go to the swept flange. So the profile I've already selected, and now it is requesting you to select the edges to set its path. So you don't need to put any fillets on the round on the edges to make it go around. So you just select the desired edges, and as you keep on selecting the edges, you will see a preview of the flange. So just with one simple sketch and using the swept length feature, we were able to easily make this tray, which otherwise could have been very difficult to make using the standard SolidWorks sheet metal feature. Let me delete it for a second. So I will use the same sketch, and now I will do the miter flange. Miter flange works the same way. Like it, you need a sketch, and then you need a path to define the directions where you want your flange to be made. So I selected the miter flange. It will automatically select the first edge, and then I can select more edges. So as we keep on selecting the edges, uh, the preview shows that yes, the feature is being made. We can control like the gaps, the flange position if we want. Like it will not work in this way because of the way we have created the sketch. Let me just click OK. So 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 with the same sketch, we were able to create two different versions of the tray. Now maybe if you want, we can fill these corners using some welding process, and then ground it off to make it smoother. Now, as we were talking about the three sheet metal feature, so let's look at them. The first was cutlass feature. I'll go to the sheet properties, and these are the different sheet properties that are generally available when you create a sheet metal part. So uh, the critical one could be the bounding box area, the cutting length for inner and outer, because you may need the bounding box to calculate the bound your blank size, which can also be uh, found from here by length and width. And then second could be you might need the cutting length of the outer and inner. That will give you the and you can add them to get a perimeter of the length which you are going to cut on the laser machine. And using these information, you can calculate how much time it may take to cut one sheet. And finally, if you have some costing added, you can also get the cost details. It also lists the material, the mass, and whatever other properties you need. You can add them using this drop down box. So let me just add one test. So let's say, okay, meeting. So if we need any additional properties, we can always add them. Then second was this sheet metal feature. So if I added this, we can add or change the fillet, the thickness, the K factor, and the auto relief details. So this particular folder or this particular feature will control the fillet, the K factor, thicknesses globally for the part. But if in case you want to use part with two different thicknesses, for example, one is 2 mm, and in the same part you want to create another body which is 3 mm, so you can control those information or those properties from these particular features. So as on you keep on adding more bodies to the same part, more sheet metal feature will be listed along under that global folder. So we just say override default parameters, and then you can change to your desired value over here. So let's switch to 1. And now my thickness is 1 millimeter, whereas my global thickness has been set to 2 millimeter. And finally, to the flat pattern. So if we unsuppress this part, you will see a preview of the flattened state, or you will see a preview of the blank you would need to create this part. Anybody wants to take a guess on this one? Unfortunately, it looks like I'll be able to see. Any guess on this one? Okay. So this is copy on the right. So on the left, the kid is copying from another person notebook, and on the right we have the right. So next we have the jog bend. Jog bend is being used for complex bends, especially when we want to create an offset face into the model. Now, as an input, you need one sketch line. It should be a single sketch line. And then you also need a base flange or a fixed face for your jog bend to start. The line geometry, it can be of any length, it can be of at any angle, so it does not need to be a perpendicular to certain face, or it does not need to be of certain length. So even a shorter length or a bigger length, it will cover the complete face or the area along the length of the line. So in this, I have a cover of a part or an automotive component, and what I have done is I have created two different sketches. So let me show you. So the first sketch is perpendicular to this face because I want the cover or the bend to be perpendicular, and the second cover or the second line I have at like 75 degree. So let's look at the first one. So I selected, you can pre-select the sketch or you can select it later on. I prefer to select it first, and then I click on the jog bend. Then now the next input you need to feed into the jog bend is to tell them, like, if it bends apart, what exactly or which phase you want to keep it fixed. So I select this area, I want to keep it fixed, and it creates a temporary point over here as a representation. And then you can point in like how much offset you want, what is the height of that jog thickness, what angle you need. So let's keep it 90. And one good option the jog bend provides you, that it gives you an option of fixed projected length, which means so SolidWorks will automatically extend the jog bend uh, to the original length. So our original length or original part or part geometry was up till this circular edge or quadrant on this circular edge. So if I select this option, SolidWorks will automatically extend the bend or to that geometry. If I uncheck it, it calculates the length after the bend and it bends it accordingly. So depending on your requirement, you can select or deselect this option. And if we click OK, this is the result we will get. Now moving on to the second, which we have at an angle. So let's go again. Now I need to tell him, okay, what is my fixed face? I'll select this side. So you need to select either side of the line entity we have selected as our fixed face. And similarly, we can give different angles. So we can tell them, okay, 45-degree, we can say fixed projected length, and even we can create, say, 10 mm. So 10 mm is going beyond the range of this offset. So let's go to 5 and then we click OK. And so just with a sketch of line and then using the jog bend, we were able to create this two complex bend, which may not have been easier to bend using the standard features in SolidWorks. Similar to this jog bend, we have something called sketch bend. There are majorly two differences between a jog bend and a sketch bend. So in sketch bend, we do not get an option of keeping the fixed projected length, but the other option which we get is like we can have more than one line in the same sketch, and SolidWorks will use all the line segments to create the bend in the geometry. And finally, like in the jog bend, the line can be of any length. Similarly, in sketch bend also, we can have the line entity made of any length. So this, I have this geometry and I want to create these two bend. One is at if perpendicular to the center line, and then the next one is at an angle, and I want to keep this area as my fixed area. So I select my edge, select edge, and I go to the sketch bend. Now, similar to jog bend, I need to provide it a fixed face. I'll say, okay, this is what I keep as my fixed area or fixed face, and then we get the similar option. So, and this angle will be applicable to all the bends which are getting generated in the sketch bend. So if we have like another line over here, another 45-degree angle bend will be created. So just with a simple sketch and one sketch bend, I was able to create this complex bend with ease. And if I look at like the flattened state, right, I get all the geometry the way I want. So even I have seen like people who have been using SolidWorks, so they will not go to these kind of tools. So what they will do is they will create this flange first, and then they will do a cut extrude over here, and then create another flange over here, and then do some rounding on the top, and finally this cut extrude, which can be little messy, will take more time, and there could be mm, dimensionally wrong, or it can prone to errors when we want to make a change. But with this sketch pen, the life is much more easier. Hem. So why we want to use an hem? So basically, the hemming means is to press the sheet metal onto its edge, and it so creating a double thickness over the edge, which helps to strengthen the edge. Sometimes the hems are used to take off the sharp edges along the edges, or even sometimes due to the cutting, if we are not using a laser machine but we are using simple sheet metal cutting tools which used to be used in older days, and still some of them being are used, especially with the parts which are being formed. Sometimes we get a rough edge, or there could be slightly imperfections along the edge. So to cover those things up, a bend is made either on the inside or on the outside, and that gives a very smooth edge experience. Uh, SOLIDWORKS allows us to do a hem on multiple edges. Even we can do the hems on the circular edges. They can be of different length and of different types. Sorry. So this is one of the feature where we will look at like how the hem tool is going to work. So we go to the hem tool on the SOLIDWORKS sheet metal toolbar. Now, the first input to the hem is that it says, okay, select an edge where you want to put an hem. It's a very high, like the radius is too high. So using this arrow button, we can change the direction. If we click on width, and then we can edit the sketch, which will reduce, actually it says width, but it should be length, uh, length of the hem tool along that edge. Then it gives us two different options, like where we want the material to be. We want to keep the material on the inside, or we want to keep the material on the outside. So what these two things means is like anything which will be bending will be over or along tangent to this edge. But if it says material outside, then the bending will start after the edge. Now we get four different type of hems. So the first one is the closed one, which is like pressing the sheet metal onto top to it. Then second we get is an open type, which will have the radius and all the lengths. Then we have a teardrop, which will form a shape like a tear. And finally we'll have an rolled type, so which is close or similar to our open type. Let's look at let's change some values. So I'll say like I need a hem for 25 millimeters, and this is the result we get. So if we flatten it, so we can see this extra material has been added to this edge. Let's try to add one more hem over here with a different type. The only drawback is like you cannot add two different type of hems in one single feature. So one single feature can have only one type of the hem, but you can select multiple different edges. This time I'm keeping the material on the inside, 50, and So we were able to create hems on two different edges at the same time with the same parameters. So this way, if we have to make any changes and if we have multi hems created in the single feature, all of them will get changed instead of like we going to one of them at single time. Cross breaks. So cross breaks are used especially for very thin sheet metal component, and the purpose of the cross break is to give strength to the sheet metal parts which are larger in area, which have a face which is larger in area, like our ducting parts or even some small trays. And the advantages of using cross break feature is like it is a very cost effective solution. Uh, so without adding any extra material or without increasing the thickness of the part, we are still able to make a part which has the strength, and it gives us the desired results when it is being put into application, like our ducts. So our ducting material is very thin, maybe around like 1 to 1.5 millimeter thick. And what we do, we do a cross break into those parts which acts as a rib along the face diagonally, and that helps to give a very good strength to those material. I'm using this example of a tray where we'll just put a cross break. So in SolidWorks, SolidWorks gives you a feature. It's called cross break, and the input is like you can just select the face, and you can define the profile, or you can define the radius and the angle you want to use for that cross break. And so no additional feature is added. Like if we go and down and look at, so no bend is added, but SolidWorks, what it does, it adds a cross line onto the selected face, which gives a representation of cross break. And when we create the manufacturing drawings for these, so looking at the drawing, the shop people will understand easily that yes, this particular face has to have a cross break. So, add a cross break to this part, and if I do a drawing for this, oops, sorry, let's make a new drawing for it. So we can see like what SolidWorks does is um, it puts a cross into the drawing itself, and using this information, the the shop floor people will understand that yes, this particular face needs a cross break, and that information can be received via the flat pattern. So it will list out like we have radius 1, bend of 90-degree, and using this information, they will understand that they need to add a cross break to this particular part. So there are special tools for creating those cross breaks. So some people uses special cross breaks if different angles are used. Otherwise, the same press bake machines tools can be used. Okay, time for another quiz. If anyone wants to guess it.
Yes, Mr. Deepak, there are some questions within the Q&A. The first one is,
Edwin, can we take the questions at the end of the presentation? So that will give me a good idea. Like then we can focus on the questions answer. Or if you want, I can answer them right away.
it's fine,
I'm open.
you can do it at the end.
Okay. Let's look at first of the questions. So we have two questions over here. One is, we will get any voucher? Sorry, Ben, I don't think so. We will be getting any vouchers, but yes, we have 25 USD dollar gift card which you can use. And then Edwin, you said, doesn't jog bend increases the volume? So volume in what sense? Like, are you talking about the big volume because of the overall shape, or the, sorry, height has increased?
I copied it from direct messages. There's someone who sent in, but I think he was
Okay.
meaning the overall volume. Overall volume.
Well, when we talk of jog bends, like if you had look at that particular geometry in the jog bend, so what we were doing is, assume like we have a spherical or we have a cylinder, and we want to put a cover on the top of it, but we do not want the cover material to be surrounded all over. So what we do is we just create four lips on the sides with a bend, which will have a hole, and then that cylinder could have threaded holes, and we can just put in the screw using those holes. So instead of like creating an inverted tub, which will have more material and which will be more costly to make, we use the four lips and we bend them using jog bend to create our locking tabs. Uh, does that answer the question, or is it something in a different direction? Okay, so this one was spreadsheet. Corner treatment. Okay. So uh, first we need to understand why we need a corner treatment, and then we can look at like what different options are available in the corner treatment. So when we create some parts using the standard SOLIDWORKS features functionality, uh, unless we are using the miter flange we have already seen, uh, if we use the standard edge flange feature, we'll not be able to get the closed corners similar to the miter flange. And in some cases, we are not able to use the miter flange. Then to fill up these corners, uh, uh, we can use the closed corner uh, options. So the best advantage or the best uh, feature of using the closed corner is that it helps to fill up the gap between the adjacent faces or the adjacent flanges. It also gives us options to create a butt joint, which is the two faces are close, or it can we can also do an overlap or underlap joint uh, into the closed corner. And this butt joint on overlap or the underlap joint, this question you may also find in the SOLIDWORKS sheet metal certification exam. So maybe you want to put a close attention to this. So we'll look at two different examples where we are filling the adjacent gap and uh, get a very close, smooth corners. And we'll also look at options to create the butt joint using the underlap and overlap options. So if you look at the feature tree, so I created a base flange, then I used the edge flange, and then I used another edge flange to create flanges on the top. But because of the application of this part, I cannot keep these corners open. Otherwise, my material which I'm going to put into this small tub may fall out, or it may drop out. So, and I do not want to change the features of this particular part because it has been used somewhere else also. And if I change it to miter flange, it might break some of the relations. So instead of doing that, what I will do is I will go to the corners and I will select the closed corner command. Now it asks you to think like which face you want to extend. I will select this. And because I have auto propagation selected and coplanar selected, it will all automatically find the other faces which should be extended, and let's select it, and this is the result we will get. And the beauty is, like, because we have four corners, we do not need the four different features. We can create everything into the same feature. So I'm just doing two of them. So with the same feature, we were able to do two corner closed at two different locations, and this way we have not changed the part geometry, but just using one additional feature, we were able to make the part similar to our design intent. Now let's look at the second example. So we have again the edge flange feature being used, but we want to close these gaps, and I'll go back to the closed corner, and this time I will select just one face, and SOLIDWORKS will automatically select the other adjacent face. Now we have three different types of corner types as we were discussing. So first one is the butt type, where both faces will extend equally towards each other. Then second, we have an option of overlap. So in this, the first selected face will overlap the second face, and if I go underlap, the faces to match, or the second face we have selected or selected by SOLIDWORKS, it will overlap the first face or the face to extend. So this is one of the question you will get into SOLIDWORKS sheet metal exam. And what we can do is, within the same feature, we can select other corners as well. So instead of creating four different corner features, we have one feature and we control everything over there. This option gives you the gap, diagonal gap we want to keep, and this option gives you the value of how much overlap or you want to create. So if we check this gap, this is 0.1 millimeter. And the 1 millimeter, it will come into picture when we have the butt joint. Continuing on to the corner treatment. So first we have seen how we can extend the adjacent faces of sheet metal part so that we get a closed corner over there. Now we want to do some different kind of corner treatments in the sheet metal parts. So we have three different type of corner breaks. We call them corner break or trim. So first is corner break, and it is used to trim the sharp corners either using fillets or chamfers. Then second is we have corner trim, and we use this to add relief to the flattened state. So in order to use the corner trim feature, the part should be in flattened state, and this feature is only added after the flat pattern. This feature will not show up in the fully bended parts. And why we need a corner treatment? Sometimes we have very bulging out type of materials in the corner. So just to avoid that situation, what we do is during the laser cutting, we cut some extra material such that when we do a bending, we get a very smooth bend around the corners. And corner relief is similar to the corner trim. The only difference is that we can add it to our bended part state, and it will be visible in the model when the part is in bended state. So let's look at all of these examples. So in this, we can see like we have some sharp edges over here. So what we can do is we can use the normal fillet or the chamfer tool to remove this sharp edges, or even or smoothen out these corners. But the problem is, like, if you have to use the fillet command, we'll have to select all the single edges. But SOLIDWORKS provides us an option called break trim corners or break corners. And what we can do is we can simply select the face, and SOLIDWORKS will automatically find out the corner it needs to trim. And then within the same tool, we can define whether we need a chamfer or we need a fillet. So depending on our need, we can select the break type, and then we can select the faces. So just three face selection instead of like six edges selection, I was able to create the desired corner break in form of a fillet. Now we have another type. So this is one of the part, and if I have to bend it in actual condition, maybe we will see some bulging of material over here, because the CAD world is slightly different than the manufacturing world. So to avoid getting into that situation, what we do some kind of a relief at the corners, so that when the bending is getting done, the material is not going to bulge out and we get a smooth corner, or we get the desired corner. And like I said, that corner trim corner trim function will only work when we have the flatted state on. So I go to the corners, and you see that only corner trim is available. I click on corner trim, and I click on the face and select collect all corners. So automatically SOLIDWORKS will create the corners. We have different types. We can select the circular, the square. So this is based on the requirement and the experience. We can select the different type. If we select centered on the bent lines, so it will automatically create the center point on the bent line. Then we can define the size of the square. Then we can say, if we want to use a ratio to the thickness, we can define the ratio. We want to keep it tangent to the bend, it will automatically calculate the bend size. And in addition, if we want to do, let me increase the size a little bit. Now, when we do a cutout over here, we will get some sharp corners here, which might not be desired. So what we can do is we can use this option, add filleted corners, and let's say make it 0.2. And so SOLIDWORKS will automatically create filleted corners along that cutout. And the beauty is, this feature will not be visible when the part is in bended state. It will only be available for the laser cutting or for your flat pattern feature. And the next one we have is the corner relief. It is same as the corner trim, and the only difference or the major difference is that you do not need to go into the flattened state to create those corner trims. First thing. Second, these corner trims will be visible into your model and may also be visible in your actual part. So we have different corners option here. So this one is a two bend corner, because only two bends are getting formed over here, whereas this is a three bend corner. So let's go to the corner, and I'll say corner relief. So we will select which corner type we want to add a relief to. So if we say two corner bend and we say collect all corners, it will automatically find that there's one corner over here, and we can give different options of circular, square, or round. So whatever you want to use, let's go with the circular. And it gives you the same option, like we centered on the bent line. Sometimes you may get some error, so we'll have to adjust size. Let's take it off or make it circular. And again, we can give the center on the bend lines. It is not working out because the center on because there are two bends. So bend line over here and one bend line will be over here, and it is getting difficult for the SOLIDWORKS to create the shape. So I'll uncheck it, and I'll switch back to the rectangular with the size of say 2, and I will tell it, okay, create some filleted corners. So again, point 2. So this cutout is being made. Let's see how it looks in the flat. So this is how it is going to look like in the flat. So if I unsuppress this was my original geometry, but to make it to really add a relief to the corner so that we get a smoother bending or easier bending, we added a relief over here. Using the same tool, let's try to create a corner break, corner relief over here. This time we will select 3 bend corner, and we can tell it to select all the corners, or if we want to select any particular corner, we can do that as well. So this time I'll go full round, and so it will automatically calculate files sizes. Oh, it filled up the corner for me. Wow. So this is how it is going to make the corner for me over here. So if I unsuppress it, this was how it was originally, and now it is creating a smooth corner over here. So depending on your workflow, depending on your need, and how expertise you are with producing sheet metal part, you can play with these options to get the desired result. You can also talk to your shop floor guys and seek their expertise on what kind of corner treatment or what kind of cutouts at the corner you should be providing, so that the actual part which is going to be made is smoother and it is easier to bend, and those people are not cursing you that who the hell made this part, and now I'm getting a lot of troubles in doing all the bendings. Uh, Anyone has used ribs in the normal sheet in the normal bendings? So in normal or in solid body modeling, we use ribs to work as a gusset. Uh, and in what we do in those bodies or features or parts, we cut out additional material to act as a rib, and then we weld those onto the areas of the part which we believe are weaker or which might need some extra strength. So in sheet metal also we does the same thing but with a different way. So what we do is, instead of adding additional material or cutting extra part and then welding them up, we use the gusset tool, or the basically the forming tool, to create a gusset like shape, which helps us in two ways. So the overall material remains the same, so the weight remains the same, and no welding operation is required. So no welding operation is required, and we can alter the geometry the way we want. So this is a bracket which is going to be used, and from the look, it might be looking like that it does not have the strength to hold some weight. So what we will do is, we'll simply add some gussets to it. So you select the gusset tool and you select a face and the second face, and it will give you a preview, and it will automatically create a virtual edge and the point from where it is positioning it. If you uncheck the offset, it will take it to the center of that point, and based on the requirement, we can provide the offset. Let's make it 20. And then we can define how you want the profile shape to be done. We can do the indent depth. Let's make it 8, or we can do the profile dimension. So depending on your need, you can select either the indent type, like how much we are pressing in, or we can uh, define it by the profile dimensions, where we have the values of D1 and D2. And of course the angle is 45 degree, but we can always change it. And then we can flip the dimension side, or we can go to the different type. So this type is usually not feasible and not recommended when you are doing gussets into the sheet metal, but sometimes they are created because of the application. But otherwise, this type is used in general, cost effective and easier to make. Then you can define the indent width, like what is the width if you want to like change the thickness, you can change the thickness. Then if you want to put drafts on the side, and if you want to do the inner and outer fillet. Of course there will be fillets when we are pressing into a sheet metal, so there will be the fillet created because of the nose fillet on the punch and the die. So, and finally, if you want to look at the different views, the partial views will not show you any fillets, but a full preview will show you the fillets from the inner and outside. So let's click OK. So back in the days when this gusset tool was not available, I do not recall like when this was available, but maybe many years back, what we used to do, we used to create this gusset as a separate body, then do a shell, then merge it with the main sheet metal body and add all these fillets manually. So it was a very time consuming task, and of course it was prone to errors, because if we made a mistake, it means we'll have to do a lot of work again. But now with the gusset tool, the life is much more easier and it looks very much nicer. This one seems very easier if anyone wants to guess. So let me see if I can do a double window. That way I can. Oh, okay. Sorry. Anybody wants to do a guess what it could be? Sorry for the technical issue we are facing. Like I'm not sure like why the program is not letting me uh, go into two different mode. Like it's not letting me select the PPT and SOLIDWORKS side by side. So I'll have to check. But let's keep it going. So the answer is because we have up on the other one side and we have yes on the other side, and if we combine them, it becomes UPS. Okay. Forming tool. You can correlate the forming tools to the gussets, but in gussets, like we have some defined profile, whereas in the forming tool, we can have different shapes. Even we can have the cutouts added along with the forming. So depending on the shape and the size, uh, uh, the forming tool can be used in variety of ways. One, it could help to provide some strength to the sheet metal by forming some ribs. It can also help you to provide some like air vents to some of the applicators, maybe to the ducts, or like to the kitchen chimney, for example, and some industrial components. The good thing about the forming tool is like once you have created a forming tool, you do not need to recreate it every time you want to use it. You can just store it into the library, and then you can drop it from the library to your sheet metal part, and the forming tool will be available over there. You can create different configurations for a forming tool, and depending on your need, you can select the configuration. So again, we have this simple part. May I request everyone to please turn off your mic, please.
Let me do it from my side. Let me turn them off.
Uh, does it allow you to turn off for a particular one?
Yes, I'm now turning them off. I think now it's
Not.
okay.
Uh,
One remaining is here.
okay,
It's
I'll continue on. So we were talking about the forming tool. So by default, SOLIDWORKS provides you a library of forming tool which you can use based on the geometry requirements. You can find them under the forming tool folder. But before you can use the forming tool folder, you need to make sure right click on this folder. Okay. And you need to select forming tool folder. Otherwise, what will happen is if we try to use any forming tool from this folder, SOLIDWORKS will prompt you that do you want to add a derived part, and instead of adding the forming tool to the sheet metal part, it will just add on one more body to your existing part. So by default, SOLIDWORKS provide you different types of forming tool. You can create your own depending on the needs. Let's use a simple extrude cut hole or maybe a countersink. So you just drag and drop onto the face, and if you press tab, you can change the face from there. And back in the days, this option was not available, but now you can also use the flip tool to change the side. You can also change the rotation, but because it's circular and the rotation angle will not make any effect. And if you have more than one configuration, you will find them into this list, and you can select that configuration. Then you have option of using link to the forming tool. Now what this option will do is, like, if you select this option and if you make any changes to the library part, that that forming tool will get updated to all of the parts where it had been used. So sometimes checking this option is helpful, and sometimes it may not be helpful because you don't want to change the parts which were done earlier or to a certain date. Then when you switch to the position, SOLIDWORKS will switch it the mode to the sketching mode, and then you can define using the dimension. I'm just doing some random dimension. And this one is basically to do the angle. So we can turn off the dimension, and if we go back to the type, or if you just click OK, this forming tool is made. And if you want to create multiple of them, you can use a linear pattern, or if you want to create across a plane, for example, if you want to create across the right plane, so you can use the mirror feature command, and then you can select in the feature that I want to create a mirror of this, and SOLIDWORKS will create a mirror of it. Let's look at one more forming tool. So let's look at rib. So say we want to add some strength to this particular area, not using the cross break because it is not a thin part, but we'll add some ribs. It's a very huge rib, but and we can change the direction, and like we're saying, we can change the angle as well. Let's make it 30. We keep rest of the position as it is, and we can just drag it. And this is the center of our, can keep it over here and define using sketches, and this forming tool is made. So likewise, different forming tools can be made. One thing you need to make sure when making or creating the forming tool, the radius used in the forming tool, like this particular radius, this sorry, this smaller radius, so whatever side it is coming to, should be higher than or equal to the sheet metal thickness. So in this case, this is 1 millimeter thick. So this radius or this radius, they should be higher or equal to the sheet metal thickness. Otherwise, SOLIDWORKS will prompt you with an error that the sheet metal thickness is higher than the radius, and the forming tool will fail to be added into the part. Normal cut. So we sometimes use cut extrudes in our solid bodies modeling, but we also have to use cutouts in the sheet metal. When we do cutouts in SolidWorks solid bodies modeling, and if the cutout is at an angle, so there is no way we can change that angle to become perpendicular to the surface. But in sheet metal, we have an option to create a cutout which could be at an angle to the face, yet the cut will be made perpendicular to the shape of the perpendicular to the face of the part. Sorry. So I have this part and I want to do cut out this hexagon through both the faces. So what I will do, I'll select this face, go to the cut extrude, and I will do through all. This is what I will do. Let me just uncheck it. Now what will happen? You will see, because these faces were at an angle to the plane of the sketch, the cutouts we have get are at very weird different angle. Now how to overcome this? When we are working in the sheet metal features, when the part is a sheet metal feature, in the cut extrude feature manager, you will see additional option of normal cut. So what this option will do, it will do the cut extrude in the same way, but the cut extrude will be the normal to the face. So let's see it. Now you will see, now the cut extrude faces are all at 90 degree on both the side. And did anyone notice that we have some bulgings over here at the corners? Reason for these bulges, like SolidWorks is trying to keep that normal cut, but because of these corners, it was not able to achieve those details, and hence it added some extra material around the corners to fulfill our demand of normal cut. Let's try to fix it. We go to the cut extrude feature again, and we have an additional option of optimized geometry. So using which, what will happen? SolidWorks will try to remove that material and try to make it smoother face instead of like those extra features over here. So instead of something protruding out, what SolidWorks did is it created a smoother face over here, and now we can easily use this part. And if you look at the flat pattern, so my flat pattern is much better compared to what it was when we did not use the optimized geometry or when we did not use the normal cut. So And if we have to laser cut this part, it will be very difficult, or it will be very costly to cut out, make this cutout at an angle. So instead, we tell SOLIDWORKS to make a normal cut first. Now it is looking better, but these bulgings, they are not looking good. So we did. So on the same time, we tell SOLIDWORKS to do a normal cut, but also optimize the geometry to make it much better. And now cutting this geometry and using this geometry for further operations will be very helpful. Extending our cut across. So uh, we can do cut across along the bend, and which could be a through cut, which means like all the material is removed. And sometimes we also need to do a blind cut, which means the cut is done to certain depth. Sorry, to certain depth. I'm saying depth. Okay. So uh, say we have one cover over here. So on one side we need the cut to remove the material completely, whereas we want to retain some thickness on the other side. So what we will do is, first we will look at like how people used to do when they were not aware of these options. So I'll look at like how cut extrude will be done. So I'm just making a random shape. So let's say this is the profile, and they will do this. Not too all. Or maybe some more depth to it. Let's say this one. So they will have to calculate how much depth will be required, and then they will be putting some fillets along these corners. And similarly for this one, they might create a sketch like this over here and do a cut extrude and then put the corners in the fillet. Not only this is time consuming, but it does not meet the design intent, and it may not give us the correct result. So what is the correct way to do these kind of cut extrude features? Let me just delete this phase. Sorry. So in SolidWorks, we have an option of called fold and unfold. So when we say unfold, we can create, we can remove the bends from the part, or we can just flatten out the desired bends from the part, and then we can fold it again. So I'll use unfold. I say keep this face as my fixed face, and I want to just unfold these two bends. So this is what we will get when we use the unfold. And now we can add any features to it. I already have a sketch over here. So let me just highlight the sketch. And I will use that sketch. It has all the details I need. And I will say the cut extrude. And I can simply say link to thickness. Now, what link to thickness means, when we are using blind, SolidWorks will automatically calculate what is the thickness of this body or this part, and it will automatically add the cutout to that thickness only. And we'll say we do not want to cut on both sides, we just want to use this one. Let's change the depth, and this is the cutout we have got. Let's go back to the folded state. I'll say fold. SolidWorks will find out which face we have selected as a fixed face. And if you want to unfold, fold every bend, we can say select all bends and click OK. So let's hide the sketch. So without doing too much of like workarounds, we get the desired cutout to our design intent. So this was a through cutout. Now let's see if we want to do a same thing on the other side, but we do not want to do a full extrude. So this unfold, cut extrude, and fold. Again, this particular question You will find it in the certification exam. So make sure you are using the proper steps to do this cutout and find, well, either the length or the volume of the part. So I'm going to do unfold again. I could have used, or let's use the same unfold feature. I'll say collect all bends. Okay. And let's unroll it. I'll unhide the sketch. Now let's check what is the thickness. So thickness is 1.25 millimeter, and we want to do a cut of just zero point 0.5 depth. So I'll select the feature, go to the cut extrude, uh, give the direction, and now instead of doing the link to thickness, I will say zero point 0.5. Oh, sorry. And then on the contour selection, I will tell it, oh, sorry, it did not change the thickness over here. Now, back in the days when these options were not available, SOLIDWORKS will fail when we used to fold it back because of the varying thickness over here. But now with this, with the recent version or with the advanced changes in SOLIDWORKS, uh, everything's work out smoothly. I'll say collect all bends. Okay. So using the steps of unfold, then cut extrude with a desired shape and the depth, and then finally using the fold tool, we were able to create the cutout across the bend. Convert to sheet metal part, like we were looking at one of the video or one of the slide where we had a very complex kind of a geometry which might take more features when we are trying to make that directly into the sheet metal part. But instead, what we did, we created a solid body and used sheet metal convert to sheet metal feature to easily convert that solid body into the sheet metal part. So let's say we want to make this rack, under table rack, where you can keep some of the books. By the looks, it looks like it has been either made using sheets on the sides, which means uh, more labor is being used. And if we have draft on the side, it will make it little more complex. But using the convert to sheet metal feature, we can easily convert it to a sheet metal part, which can be made using a single sheet metal blank, and just using the press bend, we can easily create the desired part. So this is the geometry we have, which we can say like it was made using different sides, and then they were either glued together or they were bonded together using some kind of welding or some other functionality. But to reduce the cost and to make it look nicer and aesthetically look good, we will try to convert this part into a sheet metal part using the convert to sheet metal tool. So before that, if you look at from the sheet metal perspective, it we may not be able to easily convert this part into the sheet metal part because we cannot create these kind of complex bend. So what we will do is we will create a small split in the middle. So I have created a sketch over here, and I'll go to curves, split line, select this face and click OK. So now I have two different faces. Can someone please turn off their mic, please? Okay, so we have now the face over here, and we can use the convert to sheet metal tool. So we need to provide it with a fixed face. I'll tell SOLIDWORKS, okay, this is my fixed face. And let's say I want to keep 2 millimeter thickness. And if you have sharp edges in the model, you can select the bend edges to create the bends for you. And this is the way you tell SolidWorks that where exactly you want the bends to be. And if you have fillets already added into the model, SolidWorks will automatically treat them as your bends. So I tell SolidWorks, okay, I want to keep one bend over here, one bend over here, one bend over here, and one bend over here. So SolidWorks will automatically treat these three edges, because I've not selected them, as my rip edges, basically where it is going to rip and disconnect the side faces. And then I'll say okay. Now, initially we had a solid a part which was made using solid modeling, which could be complex in manufacturing and was not cost effective. So what we did, we simply converted it to a sheet metal part, which is now easier to make using a single sheet metal part, and you only need to do laser cutting and bending, and no extra operations may be required to produce this part, which means if we have to do uh, mass manufacturing for this component, we will be able to do it easily. Now, if you want to add aesthetics, you can add some ribs over here, or maybe you can add uh, the corner trims, which we have learned. So let's say, so we can add some corner treatments, and that way we can easily convert a complex part into a sheet metal part. Let me just edit this feature to show you a few more things. So we have two more options over here. Like we have few more options over here. So if you want to use a different thickness, then you can select this option over at default parameters, and then we can change, uh, say, to a different thickness, or maybe we can reduce. If we want to reduce it to 1.2, we can do that. Radius we can change, so it will be changed. And if you want to do a reverse thickness of the face we selected, so initially it was on the other direction of this face selected, but now we want to keep it on the same direction of the face selected as a fixed face. So SolidWorks will change the direction and keep body option. What with this option, what will happen is SolidWorks will keep the original body as it is, and it will create a new sheet metal body for you. So this is sometimes helpful when you want to compare the original body with the outcome, but make sure you delete this body later on, or you set it to uh, hidden mode. Otherwise, it can create confusion, or you can also, if it is in sheet metal, sorry, if it is in cut list, you can also exclude it from the cut list, so that when SolidWorks consider anything in the cut list, it will only look at the sheet metal body. So let's remove it. And not only the single body, we can also convert a body into multiple bodies, and within the same part. And that is where you may find this keep body option helpful, so that you do not need to create a copy of the body to create the second body. For example, if we want to do a split, a half on this side and half on this side as two separate parts, so we could have split the body into two over here, then converted first half over here using the original body, and by keeping this option checked, the original body will be retained, and we can use this other side to create a second body. So depending on the need, you can play with these options. Any guesses onto this one? This is very critical these days, and it is related to the network. Anybody wants to guess? Guess. Oh yes, this is correct. The answer is Wi-Fi. Okay, so let's do a recap of what different feature we looked at today, and then we can jump on to the question and answer, and finally to the quiz. So we looked at different type of sheet metal components and what different manufacturing processes are being used these days to create sheet metal parts. We looked at the swept flange for creating the complex bend. In addition to the swept flange, we can also use the miter flange, and it works the same way as the swept flange. The only difference is we do not get a smoothen out corner, so we might need to add additional welding onto the corners to make them smooth. We looked at jog bend and sketch bend, which are two similar options giving different options in bending just with the help of a sketch segment, and we were able to do complex bend in very simple steps and with very ease. We used gusset hem and forming tools in different ways uh, to strengthen the sheet metal part and also add some aesthetics to them, especially uh, when we had improper edges or when we have sharp edges. So we used the hem tool over there. With the forming tool, we not only did the strength, but we can also create uh, the vents for the sheet metal part to let the air pass out, or maybe some toxic gases easily pass out without doing too much of workarounds. For the forming tool also, we can do complex cuts. We can create a forming tool, and the beauty of the forming tool is once you have created a forming tool, you do not need to recreate it every time. You can just drag and drop it from the library, and you can create different variations of the sizes by using or optimize by utilizing the configurations in it. For thin sheet metal parts, we have the options to use cross breaks, and we do not need no workarounds or any additional notes to be added into the drawing. Just add this feature to your model, and SolidWorks drawings will automatically add a bend line over there with the desired bending note. And uh, the shop people will, looking at the drawing, will understand, okay, this particular part needs a cross break, and at this particular phase with these details or these values. We looked at the closed corner option to close the gap between the adjacent faces, whether it was extending the material or whether it was closing the gap by doing a butt or overlap or underlap joints. We looked at different corner treatments as well, which helped us to do to remove the sharp edges and also to provide reliefs around the bendage around the corners to make them helpful or smoothen out the bends and make them easier in manufacturing. And we looked at the normal cut and cut across the bend. So with the normal cut, we were able to cut the geometry which was perpendicular or normal to the face, and we were also able to use the optimize face option, optimize geometry option, which helped us to remove some of the unwanted material from the part. And we looked at the cut across the bend, which could be helpful to maintain the design intent, and the steps were easier. Just unfold your part, create the cutout either through or to a certain thickness, and then fold it back. And finally, we converted a complex looking part into a sheet metal part using convert to sheet metal tool. So just on few clicks, we were able to convert the complex part to sheet metal part. So this helped us in cost saving as well as making it easier to manufacture. So I'll take the questions and answer now, and then we can jump on to the quiz.
Yes, the first question is within the Q&A. It says, can you flatten your sheet metal model with a Gusset onto it?
Yes, you can flatten your sheet metal part. So let me just share my screen back again, and I will open up the cassette part for you. Okay. So this is the part we were looking at, and if I create a quick gusset over here, I'm just not looking at this material. So when we want to do a flatten, so what we have done over here, we have not added any additional material. When we actually create the gusset and the physical part, we do not add any additional material. So what we do is, by using the forming tool, which is of the gusset, we try to form the material, or we try to push the material. Same way we do it in the SOLIDWORKS. So, and if I want to do a flattened state, this is where we get. Uh, does that answer the question?
According to my point of view, I
Yeah.
think, yeah, as in that is the solution. I've seen it.
Yeah. So this is how your blank will look like, and after the bending, the gusset will be created using special tool, but you do not add any extra material to the part. You basically just push the material to create that gusset, and it is same for the forming tool as well. That you do not add any extra material to it. You just use the same material and you push the shape from one side, and the formation is made on the other side. Uh, Okay, the next question is, can you show the slot feature on intersecting parts for crossing box style? So is that tab and slot feature? Okay, let me just create a quick example. Oh, so right now I have two different bodies, right? And I want to provide some options to align these without the need of any jigs and fixture. So in SOLIDWORKS, we have option called tab and slot. So I want to add tab along this edge, and this is my face, right? You can select the offset you want, or equal spacing lengths. So different options you can select. You can select the sizes or the offset. So first thing is the offset, and then second is the size. Then this is the length. What is the length of the tab you want? I said 25. Then sometimes people use up to the surface, which we have selected over this face, and sometimes they do not want it to be up to the face and want to keep it blind. So let's say we want to keep it 0.5, though uh, it is not recommended to keep the tab height lesser than the thickness. So I'll make it 1. or maybe, oh, sorry, let's make it at least 1.5. Then what kind of edges you want, like you want to keep them sharp, you want a chamfered corner, or you want a filleted corner. So let's use a filleted or a chamfer corner of 1 millimeter thickness. For the slot, um, it's no through cut is usually used when you do not want to expose the cutouts on this face, maybe because this face is an aesthetic face, but otherwise we use a normal cut, and using this we can provide them and around the faces, sorry, the gap around the tab, or we can use an equal offset. And then what kind of corner you want, usually we keep it sharp corner, and the moment we click it OK, SolidWorks will create a cutout in the base part, and it will add a tab on the top part. So if I hide this body, this is how my part will look like. And if I hide this one, this is how it will look like. Even if this particular body, let's move it on this one on the inner side. Let's keep it in the middle. So we still get the same results. So does this answer your question, Tiffy?
There is also another question in the chat.
Yeah.
There's also another question in the chat.
Yes, it says it is possible to give slot command in the curve direction. I believe the answer is yes. And let's look at it at that one also. So, so let's say we want to add tabs along this edge. Okay. So let me just extend it to the other side as well. Okay, so let's go to the tab and slot feature. I'll just edit it, and choose a new feature. And then this is my face. I'm not using any offset, just using a spacing of 30, or let's do an offset of 10, 10 from the each side. So this is the curve we will get, and this is how it will make. And if we have to flatten it, this is how we will get the flattened state. I hope that answered the question for Ajay. So, any more questions, or are we ready to take the quiz?
I think there are no more questions. Now we are going to take the quiz, and I have shared the link to the quiz within the chat, and also there is a surprise gift to all attendees. That is CSWA and CSWP certification. After the quiz, I will share a link. Yeah, the reason is I've been visiting most of the universities in Uganda. I've been giving out to students, and also I decided at the end of this, for students who will attend, maybe they did not manage to make it to the physical sessions, they'll be getting CSWA and CSWP. So CSWA and CSWP, it is a surprise gift to all the attendees with a special gift card of $25 to the winner of the quiz. So the link to the quiz is already in the chat.
Yeah, I'll be
After
sharing
that,
it on the screen as well. So sorry to
okay.
cut in middle. So if you have any questions, you can reach out to me on my email ID, and I would appreciate if I can get comments and feedback on today's presentation, and what do you think was helpful and what do you think was completely disaster. So I'll be happy to take both positive and negative feedback or comments uh, on the presentation. And if you want to reach out through social media, so these are some of the platforms where you can find me with the handle of Gupta 9665. So you can always reach out to me with your questions or with your feedback. Uh, that will help me to improve uh, myself as well as, and I may learn something new from you guys as well. So with that, uh, it's a quiz time. So you can go this link, which is already shared, or you can scan this code as well. And I will start the quiz in a minute. Okay. So we have around like 32 people. So there is like a series of 9 questions, and all of them are from what we have discussed during the session. So if you give a faster answer, you will get some additional points. So the answer for this question was to create an offset section in the sheet metal face. Sorry. Why- For some reason, sorry, I was on the last slide of the quiz and I didn't notice it. So Okay, the answer is flat pattern, and none people found it good. Correct. Okay, so these are the scores. Here we have the next question coming in. This is my second time using this application for the quiz, and I'm still learning it how to use it correctly. So the correct answer is convert to sheet metal. So here we have the next question. It's good to see so many attendees are giving correct answers. We will be declaring the results based on the eight questions, because question number nine we have already worked out, and somehow the presentation had to be restarted. So next question will be the last questions, and we'll get a winner. So this is the last question. Show your best. Okay, I will share the final result. So let me just hide it and share the screen. So Paul is the winner of today's quiz, with Abdul competing close to him. So Paul, you can contact Edwin after the meeting, and he will help you get your uh, prize. So can we have a small clap for Paul?
Actually, I congratulate Paul for making it to the win of the quiz, because this is all about being fast and choosing the right answer. Yeah, so Paul, let me just drop my WhatsApp and then you text me. I get your details. So Paul, that is my WhatsApp within the chat. Text me and I'll get your details. And also, Paul, I'm going to request you first send your WhatsApp contact. I need your WhatsApp contact, Paul, within the chat. Otherwise, let me drop also the link for the SWA and SWP as a surprise gift to all those who have participated. Yes, Paul, I have seen your contact. Thank you. I'm going to contact you. So there is a link, and you can there is a link within the chat. You can be registering. So I'll close the link after 5 minutes. So at this moment, I'd like to thank Deepak Gupta for making this session wonderful, and I have learned a lot of things, because what I got from Deepak was every day is another chance to win. No matter how long I've been using the software, That's why even at the start of this session and at the end, he said, when you give your compliment and comments, he will also learn from you. Yeah, so Mr. Deepak, thanks for the session. I'm so grateful that you accepted my invitation to the Uganda SWUG. And also thanks for the guidance throughout this journey as I started also to use my SOLIDWORKS some time back because you are among the people I first contacted. So thanks for everything and thanks for presenting. I believe it has been a fruitful and wonderful session to all of us, and we are going to put in more effort to explore more of what you have been zooming to us, and we see how it can be applied in the field. To those who are engineers already in the field, they already know the concepts, and to us who are the students, we believe we are going to explore more when you come to the practical hands-on. So thank you, Mr. Deepak, for the support as Uganda SWUG. I welcome and I recognize the presence of the SWUG leader for, is it Tanzania? That is Edward is within. Thanks for joining, and and everyone who has joined in. So, Mr. Deepak, the floor is yours. You can give your conclusion remarks.
Thank you, Edwin, again for giving me this opportunity to share my knowledge with so many of you. And like I said, and even Edwin added, I would appreciate any comments, feedback from you guys. So that will help me to learn something new, which, like Ajay asked me, uh, can we do a tab and slot on the curve? I do recall that I have used the tab and slot maybe a couple of years back onto the curved face, but I had not been using it recently. It's more of like flat edges. So that helped me recall that yes, it can be used. So thanks. That helps me recall something which I might not have used for a long time.
Okay, Mr. Deepak, I believe we shall be forwarding in our comments and supplements, and for any
Yeah.
help that we need on LinkedIn, probably yes, we shall. So,
Yeah.
members,
Thank you. I appreciate that. Yeah.
yes, thank you, Mr. Deepak. We shall keep in touch as I look forward to host you for in other departments that could be drawing tools. I remember you are good in drawing tools, you are good in everything. So this time round I decided sheet metal. Next time could be drawing tools, could be API, any topic. So we shall keep in touch. And to the SWAG members, thank you for making it a point. To the non-SWAG members from other countries, I welcome you. I recognize all your presence. Thanks for making it a point. There is a link for SWA and SWP as a surprise gift to whoever who has joined in the chat. And with those remarks, thanks for coming. You can leave the Bevy page at your own convenience. Thanks. Nice time. Take care. Mr. Park, nice time in India. See you soon. I think
Yeah. See you
2027 I'll
soon.
make
Talk to you soon. Yeah. Yeah.
2027 I'll make it to the 3D experience world. 2026 is impossible.
Yeah. Maybe next week. Yeah.
Okay.
Let's see. Yeah. Okay. Thank you.
Baba, you can leave at your own convenience. Don't forget to fill in the form because after some time I'm going to deactivate it and exams will be on soon.
Thank you. Bye bye, everyone.